Just a quick follow-up video to our person roster. So in class, most of you had done pretty well on this, but what we're going to do is we're going to initialize the roster. Now, keep in mind, when we do this, we're creating memory to hold an array, all right? Memory address, and create an array, you have to say how big it is. So we have to specify the dimension, which is going to be the length of either of those two arrays. That's because we're going to take every name and age, combine it to make a person. You have to have a space for that person. So now I'm going to loop through all the indexes that belong to the roster. And for every index, I'm going to put in a valid person reference. Some groups did this in one line of code, some did two, some did four. There's a lot of different ways you can do it. Ultimately, we're making a person, and according to person's constructor, had to reference for ourselves, a person is a name and an age. So we go to the names array, name, string, the ages array, get an A, hint, and now we have a person. And then that person can go into our roster. And so yeah, I could have done that, in one. Oops, I did forget one thing though. I got to say where it's going in the roster. All right. So I could have just put the person as I created the roster. I didn't have to name them. And like I said, in some groups, this, one line, two lines, four lines, whatever. Okay. But we should pause for a second, run our code, make sure that we're seeing the constructor connect, because if not, we're not going to be able to do anything else right. The constructor is responsible for actually putting the person objects in there. All right, now we're ready to try some of these index names here. So anytime we're tracking an index, I like to just go ahead and track the index. Even though we're looking for a name, I'm going to use the index to go into the array, get a person, and then get their name from the person. The index is going to take it there. So it's really the only thing that I need to track. Remember, when I let int index equal 0, I'm assuming that 0 is the index that takes me to the person with the first alphabetical name. I don't really think that's true, so I'm going to loop through all of the other indexes and give them their chance, labeled as the first alphabetical name. For you don't have access to the names right now. It was erased from memory as we left the constructor. All right, so like I was saying, what I'm going to do is from the array, I can get a person. Okay, so if I go into the roster and I reference where I'm talking, what comes back to me is a person. From a person, okay, I can get their name, right? So if I have a person like person P, there's a get name method that belongs to the person class, and I could reference that here. Now I've got a string name. If I have a string, I can call the Compareto method from the string class on it. It requires another string. If it comes alphabetically prior to that string, then I'll get a negative number. If I get a negative number, that means that my index wasn't taking me to the first alphabetical string. The I index is better, and I want to keep it. And in the end, I should be left with the best one. Now, what do I put in here? Well, I have to put the name that I think is the first alphabetical name. That name is found in the roster at the index that I'm tracking, okay? However, be careful, that's still a person. We have to extract from that person what their name is. And we should see the number 4 appear here, because in this particular array, Austin is first, and you count down starting at 0, 0, 1, 2, 3, 4. Austin's at index 4 in the array. That's why we're getting 4. All right, we could take all of this code, okay, and reuse it here to do the last alphabetical index. The only thing I could either change the order of the arguments within the compare method, or I could just change less than to greater than. And we should see 2 appear this time. Xavier 0, 1, 2. Even though he's the third name, he's at index 2. Jordan Charles Xavier, and that's why we're seeing show up here. We're now going to use these methods, which remember gave us integers, right? 4 and 2, figure out how to swap Austin and Xavier within the array. So I'm going to go ahead and grab the two indexes that come out of these two methods, and I'm going to then use those indexes to pull off a roster swap between these two persons. Typically, when we do a swap, we use 3 lines of code, and I'm going to use 3 lines of code here. So first I go into the roster at index A and I grab the person from there, and then I can overwrite index A's person. And it's really important for me to label that first line as a person because anything coming in or out of this array has to be type person. I did see some groups trying to put int or string there, but we want to actually grab the entire person reference. So if we look here, we see Xavier and Austin. We're going to see those two names switch, Austin and then Xavier now. And counting the end names, we'll go ahead and put in our counter. Okay. We'll run a loop. You could actually use an enhanced for loop here since we just want to see every person that belongs to the roster. We don't really care what order we see them in. And we're ask a question of them. The easiest way to do this is to rely on the index of method. However, the index of method can only be applied to a string. We have a person coming to us from the array. So first we have to get the string from the person. Then we can apply the index of method and check for a lowercase n. Index of would tell me -1 if there was no n in their name. So as long as I don't get -1, then I can go ahead and count that. There's 4 names, Jordan, Austin, Ignace, and John, that all have a lowercase letter n. And we should see that show up here, right? 4. And every person gets older. Again, we can actually loop through here with an enhanced loop. So using an enhanced loop, this has to be a mutable object, and it is. If you go check the person class, there was a method called add years. And if you put a number in there, you can add years. Now, earlier when I used index of, you'll notice that I had to get their name first. That's because index of was a string method. So I had to first convert the objects to a string. I shouldn't say convert, but I had to pull out the string quality from it. Okay, I didn't get the age here. That wouldn't work. Age is an int, and this is not an int method. This is a person method. So I'm applying it directly to the person reference that I have. And when I run it, we should see like all of their ages increase by 1 the third time that it prints the roster. And we see that right here. Okay, all right, looks perfect.